Okay, so the volume is how many non-overlapping cube units. So how many cubes fit into each polyhedron or 3D shape that we have. Now, Cavalari's principle is something new to us. I don't think it's on your notes. But it says that if two 3D shapes have the same height and have the same cross-sectional area at every level, they have the same volume. So that works really. I'm trying to see it. You guys remember CDs?
Does anyone have any CDs? Yeah.
It's not that old.
Yeah.
I have Justin Bieber one. Me too.
So if I have the volume of this right cylinder, is that volume going to change if someone comes and knocks it over a little bit?
Are there any less CDs in the stack now?
No, not right. So we go back. Cavalari's principle says that even though it's slanted, if it has the same height, it's going to have the same volume. So our volume of a prism with area base B and height is just base times height. It should be on your notes. Just like with surface area, this B changes. That capital B is whatever formula you're going to use for that base area. So that's in 2D land. So in this example, what is our base? What would our capital B be in this example?
What shape is the capital B?
Triangle.
Triangle.
What's the area? Base times divided by 2. Base times divided by 2. So you gotta remember what that capital B changes into. Okay. The volume of a prism is cube. They're kind of special ones, but they're saying the same thing. The base is just length times width, and then you multiply it by the height. Okay, so try this example. Find the volume of a prism. Round to the nearest tenth if you need to.
195 centimeters cubed.
195 centimeters cubed. Cubed. We got that because we did length times width times height. We found the base area, length and width, and then multiplied it by the height.
Everyone right now, get out your blue sheet. Get out your blue sheet, get out your blue sheet.
You do not stop.
On your blue sheet, what is the volume of a prism? Find it on your blue sheet so you know where it's at.
Base times area.
The volume is capital BH, right? But I thought we just said it was length times width times height.
Base area is
Yeah, what is capital B?
13 times.
It's the base area. And what shape is the base?
rectangle.
It's a rectangle. And what's the area of a rectangle? Yeah, or you can call that length times width, right? So B is length times width times height. Does that make sense? So it's the same thing. It's saying the same thing. They just say capital BH, so it applies to all prisms. Because if it's an octagonal prism, can we just do length times width times height? No, because the base is an octagon. You'd have to do the area of the octagon. It's not just a rectangle. So length times width times height, it's like a shortcut if it's a rectangular prism. And also, if it's a cube, what is that going to be? What is my length, my width, and my height of a cube? It's all the same. So S times S times S is S cubed. It's all kind of the same thing. They're just kind of shortening it and writing it in different ways. Okay? Circular prism. What's a circular prism?
So we use our volume equals base times height. What is our base going to be? What is our capital B? How do I
What shape is the base?
Area of
Half of the times the perimeter.
Good.
the one.
So you should know that a hexagon is 1/2 AP. All regular polygons. What does regular mean again?
Equilateral.
Yeah, it says that in the directions. It says it's a regular hexagonal prism. So we look at regular polygon, 1/2 AP.
So what do we know out of this formula so far? B. What's P?
45.
Yeah.
45.
No,
So
no,
54.
54.
54. 9 times 6. So 9 feet by the 6 sides gives us a perimeter of 54 feet. What's the height? Oh. 12.
Well,
What's the apothem? Just had to do something very similar to this on your snapshot.
Pythagorean.
Pythagorean.
You cannot do the second here.
So if we're back in 2D land,
360 divided by. Yeah, then find your central angle.
9 foot side.
This is what I did and I got it wrong.
How do we find the central angle?
360 divided by 6.
360 divided by 6 gives us this whole thing.
Cut it half.
And then we want only half of it.
60. So 30.
30 degrees.
4.5 would be the
Tangent
bottom.
of 30 equals.
We're looking for the apothem, and then we know this opposite side. It's half of the side length.
Tangent of 4.5 over A. Oh.
X is down low, so we need to switch now. So A is equal to.
Objections don't work.
So get out your calculator. Make sure your calculator is in degree mode.
Alright.
Gotta do that.
You have any-
So 4.5 divided by tangent of 30.
Watch out.
7.84. 7.794. I'm just gonna leave it in there.
You guys, what? We're gonna show you another shortcut that's gonna save you, and you'll have these yellow calculators all through your senior year of high school. Every teacher has them, so this is something that you can use for now on. So now we have to type that whole thing in, right? But what's wrong with just calling it 7.79?
You're not exact.
You're chopping stuff off. So watch how Miss Torres types this into the calculator, where you don't have to do that.
You're gonna do 0.5
Do
times.
this.
Do it. Then arrow up,
See how it highlights the last answer in black?
and then hit enter. It's like a copy and paste. Copies your answer, brings it. All of those decimals that keep going, brings it down, and then you can multiply by the rest.
So that's the most accurate way to put this into your calculator. Is use the answer that the calculator gives you.
And
What are we
it
finding
asks
out?
us to round it to the nearest tenth. So rounding to the nearest tenth.
Three.
Just 1 3. And it's feet cubed. Anytime you're doing volume, it should be cubed. For cylinders, we still have base times height, but what's the base area for a cylinder?
For right cylinder, it's
For any cylinder ever, what's
What
a
shape
base?
is the base?
Pi r squared.
It's a circle, so the area of a circle is pi r squared, and then you multiply it by the height. Does it matter if it's a right cylinder? Or if someone kind of sat on it and moved it over a little bit? Doesn't matter. Cavalry's principle tells us that as long as they have the same height, it's going to be a base times height. So we're finding the volume and giving our answer in terms of pi.
So if
And round
Pi
to
squared h. Okay. So our volume is still base times height. But what's the capital B in this case?
pi r squared h.
Just pi r squared to the base, and then times pi. Okay, so we have a radius of 9, half of the diameter. Be careful. So pi times 9 squared. What's the height? 14.
We need to exponent first.
Order of multiplication doesn't matter. What? Order of multiplication doesn't matter, but you have to do your exponent first. So PEMDAS. 9 squared times 14.
times 5. Oh, wait, is it?
That's not what I got. I got like 3,000.
pi, and just because it's in terms of pi doesn't mean it doesn't get a label.
Don't put the pi in the calculator.
So it's inches cubed.
And yeah, but that's the way yeah, she's saying she got something different.
And then we also want it rounded to the nearest tenth, so now I can take that answer and multiply it by pi. Hey, me too.
You need to be able to do both of them though.
How do I round it to the nearest tenth? 5 or 6? 6 inches cubed. Alright, so now we're finding the volume of composite shapes. So we're taking this sphere, or not the sphere, this cylinder, and we're carving out a prism out of it. So it'll be like a hollow.
Just like that, right?
So to hollow it out, we need to find the total volume. So our total.
What's the largest shape there? The cylinder is the whole thing, right?
Are we still on like a...
And then we need to subtract away what shape is in the middle. A square prism.
I don't know if it's a square.
Oh yeah, I do. Hey, what's our volume formula for a cylinder? Pi r squared h. Volume of your area of your base times the height minus what's our volume formula for a square prism.
Any prism.
Base
All
Base
prisms.
area times pi.
Base area times height.
Do we know any side lengths to use our normal square formula for area?
No.
Yeah.
We could.
Right there.
Using the rounded formula, let's plug in what we know. Do we know the radius of the cylinder?
Yeah.
3.
Yeah,
Yeah,
3.
3.
Yeah, it's 3.
Yep. So pi times 3 squared. What's the height from base to base?
5.
Times 1/2 times what's the first diagonal going to be?
6.
6.
The other diagonal is going to be the exact same. The square. Then the height from base to base.
5.
It's the same, right? Because they're inside each other. So to the nearest tenth would be 51.4. What are our units?
Centimeters cubed. So it's 1/3 that P is still the base of the pyramid. So
Square.
that's going to change. And then times the height. So using our area formula, 1/3 times the base
I was like,
area,
look at that
which
number.
is just the
Yeah.
side length
Guys, in the back,
squared,
stop talking.
times the height, which they give us is 14. We should get 374,
378.
378
Yes,
centimeters squared,
Yeah, cute.
cubed.
So the formula for volume of the cone is 1/3 pi r squared h. So over here, you guys can answer this. What is this called? The slant height. But for volume, we need the height, also known as the altitude. So we need to find this. So we can use the Pythagorean theorem, just like we've done a few times here. The height is right here. We need to know what this is. So we can do 16 squared plus, I'll call this A for altitude. A squared equals 34 squared. That comes out to, you can take your time to do that, that comes out to 30 when you find that. Okay. So now to finish off our formula, we do 1/3 pi, and then the radius, we know it's 16, so we're going to go 16 squared times the height. That's the altitude, and we just found it. It's 30. So put that all together. You can do it in terms of pi or as a decimal. It doesn't really say. So if you put that in the calculator, you should get 8,042.4 centimeters cubed. And that is your final answer for the volume of the cone. practice this one on your own. All you have to do is add a cone to a cylinder to a cone.